Okay, welcome to Integrated Geometry. This is Mr. Dang. I miss seeing you guys. Okay, so can you give me your undivided attention? The lessons today will be from 10.2 and 10.1 and 10.2, which is circles, properties of tangents, and the arc measures. You guys are very familiar with this, childhood images, which is circles, and then you have radius and diameter. Circle based on the ancient concept, and that is the most perfect shape in the world. Okay, so let's look at the vocabulary of a circle, and then we'll look at the nature and the properties of circle as well. To have a perfect circle, you must have a center. Okay, there we go. So I call it center O. This is how the notation, this is how you write circle with center O. This is how you do. That circle right there and the letter O, which is, it looks kind of confusing with the two small tiny zero right there. How about call it circle C? Circle with center C. This is how you write circle, and there we go. Circle with center C. Okay, that's the notation of it, the geometric notation for that. Let's deal with first of all, the center. We're done. Let's go with the next one, which is the radius. Radius, what is the radius? Okay, before I move into the radius, let's define circle based on the geometric concept. Circle, by definition, is the set of all points in a plane that are equidistant from its center. Okay, so if you take a ruler and you connect from the center to any point on the circle. There we go. Let's call this point right here is, let's say, P. Then you say CP is the radius. Radius. Okay. I need to write it out right there. So radius technically is the distance from the center to any point on the circle. And all radius of the same circle are congruent. Okay. All radii of the same circle are congruent. The next one is the diameter. Okay, you can have multiple diameters in a circle, guys. So that diameter is, you just extend the radius from the center to the other side of the circle and land on that. Let's call this is Q. So you see on the circle, the line that runs, or the segment, let's put in a geometric notation, the segment that has both ends on the circle and it runs through the center, that is the diameter. And by nature, diameter is the longest chord that you can find in the circle. Notice I just gave you a big word as well. That is chord. There we go. There we go. Chord. Define chord. Here we go. Chord is the segment whose endpoints are on the circle. So you can have really multiple chords on the circle. Let's say another chord's right here. Okay, let's say segment. Chord is the segment whose endpoints are on a circle. Let's give the name for this chord right here. That's the chord. Okay, let's see. This is V and this is W. There we go. So you can have multiple chords on the circle whose endpoints on the circle. And by nature, you see that the diameter is also a chord. And it is the longest chord that you can find on the same circle. Now, you have the radius, you have the diameter, you have the center, you have the chord. What's next? And that is, what if you have a line? Okay, a line that on a plane that touches the circle at only one point. What is that line called in relating to the circle? Here we go. If Mr. Dang draw, okay, I'm going to use another color so you can see. Use a line in the plane that has only one common point to the circle at the point Q right there, okay? And the line right here, you call it the line L, for example, the line L, okay? And it touches the circle at only one point in the same plane right here. This line right here, okay, line L is called the tangent line to the circle, the tangent line to the circle. So to illustrate correctly, geometrically, that's the line right there, okay? And it touches the circle at only one point. So this line L is called the tangent line. Can anyone tell me, so what is the point Q that the line L and the circle C have in common? That point Q in common, what do they call it? There we go. It is called, point Q is called point of tangency, okay? Point of tangency, and you can have multiple, point of tangency between a circle and a line that has what? One, common point right there. This is, there we go, suppose, okay guys, this is about another U. There we go. This is another line, let's say line M, okay? The point U right here is called the point of tangency, since the line M is the tangent line to the circle C. So we're going through the center, radius, diameter, chord, and now there is another concept that you are, wondering, Mr. Dan, what if the chord whose endpoints, notice the chord is the segment, which is, limited. Let's go into the next concept, and that is secant. Wow. Secant. Mr. Dan, what does secant look like in relating to the circle? Secant is a line, but instead of touching the line at one point, that secant just runs through the circle. For example, here we go. You have a line that just runs through the circle, okay? And it cuts the circle at 2 points. There we go. Now, to illustrate that line, you do the geometric notation. There we go. And it cuts the circle at 2 points. Let's call this is X, and let's call this is Y. There we go. This is called the secant. Secant is a line that intersects a circle in 2 points, and it keeps running. So these are the vocabulary that I like for you to just really memorize it. To speak your geometric language fluently, you gotta know your vocabulary, which are center, radius, diameter, chord, secant, and tangent, and point of tangency. How about a little biblical integration? Okay, the segment is right here. There we go, a segment, which is 2 endpoints. Okay, it is a finite value. A ray has a beginning point, but then the arrow keeps running to the end. I think I will not go there right now. I will move your biblical integration at another lesson then, okay? Because I want to illustrate something, but just focus on the content first. Capture all of this for me. Just the vocabulary: center, radius, diameter, chord, secant, tangent, and point of tangency. Now we are going to write your geometry correctly. This is how you will look at the example. Look at the example right here. I look at your textbook example, and I will redraw this so that you can see things more clear. Okay, let me pause the next video for you.